Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat? If I'm visible as well as equally audible, then we would start right away. Okay, it's sharp 3 and we would start in a bit. Okay. Let me check. Chat, if I'm visible as well as equally audible. Okay, sorry for the dual audio. Okay, let me check the other channel where I would be online. Okay. Just let me know if there is any lag in the video or not. Just let me know. Because today I'm live in two channel consecutively. So it might be the case that you might face a lag. Okay. We are good to go, so we would start. Okay. So today we would be discussing the problem prerequisite task. Okay. And this is a problem which is related to graph. And the next thing is that the company tags are quite interesting. Okay. The company tags are Amazon, Apple, Facebook, Google, Microsoft, and Twitter. And the success percentage is 50%, and the problem is a medium level problem. Okay, so let's see the problem statement. Okay. So there we are given a total of n tasks labeled from 0 to n minus 1. Some tasks may have prerequisite. What do you mean by prerequisite? Prerequisite means that we need to finish that requirement to do that particular task. Suppose in while applying for a CP course, the basic prerequisite is knowing a basic language, getting a hold of a language. Like you need to know the basics of C++, then only you can go with the learning of CP course. Okay. For example, just for people who are with me, just if there is any lag in the video, just let me know. Okay. For example, the to do the task 0, you have to do complete the task 1, which is expressed as a pair 0 and then 1. Okay. What do you mean is, suppose if the pair consists of 1 and 2, then for completing the task 1, you need to perform the task 2 itself. Okay, good to go. So we would proceed. So we are given a total number of tasks n and a list of prerequisite pairs, and find if it is possible to finish all tasks. Okay, good to go. So now we would try to solve this problem, but first we would look at the sample test case. Okay, no lag, absolutely. Thank you, Manav. Thank you so much. Okay. Okay, so we are given 3 pairs and the number of tasks is 4. Okay, P is the number of pairs only, na? Yeah, prerequisite pairs. Yeah. So we are given to complete the task 1, we need to complete the task 0. Okay, so let us at first write what are the number of tasks. The number of tasks are 0, 1, 2, and 3. This is what we would write. And then to complete the task 1, we need to complete the task 0. Okay. So we would go to 0 and finish it. Finished. And now we would see that if 0 is connected to any task or not. Because to complete the task 0, we need to perform the prerequisite of task 0 also. Okay. So we saw that there is no prerequisite. So we have completed the task 0. So 1 is now complete. Good to go. Pankhudi Gupta, hello. Okay. So now to complete the task 2, we need to complete the task 1. And task 1 is already completed. So task 1 is completed. And now task 2 will also be completed because we are already done task 1. Now For task 3, we need to perform the task 2, and task 2 is already done. So we are concerned about the task 3. Good to go. So now we can perform every task in the given order and there won't arise any problem. Okay. So now if only this test case was given, it might be a little difficult to think about the solution. Okay. But the second example drives us to the solution where it becomes clear observation. Okay, I would show you how. Just do like the same thing. We would write the task 0 and task 1 because 0 to n minus 1. Okay. Now we would start. For doing the task 1, we need to perform the task 0. Okay. Now to perform the task 0, I need to perform the task 1. Okay, now I would show you what this is done. 1 is telling to do task 0 first. And 0 is telling the task to do 1 itself. Okay, what I am trying to tell is, I am telling Manav to do a task. Manav is trying to tell Anmol to do a task. And Anmol is trying to do the same task, telling me that Siddharth do the same task. Okay, this is what is happening. The thing is that the task won't be completed because we would start keeping our blame. We would try to be a blame game. Okay, 1 is telling to 0, 0 is telling to 1. And this creates a cycle of blame game. And what it does is, it shows that it is quite clear, okay, quite clear that nothing to worry about other things. If cycle, then no, else yes. And what do you mean by cycle? Cycle means never ending situation. Like we would do in an infinity loop. We would go, and at the end the task won't be completed. Okay. So now is this idea clear or not? Can I have a quick +1 in the chat? Thus, is this idea clear or not? How I come to this solution? This is important. Am I clear with this or not? After that, we would see how can we try to implement this, how we would solve this. These are all the different cases, but I want to show you that thing. Just tell me if this is clear or not. Let me see the other channel. What are the comments there? The other channel has no comments for now. Can I have a quick +1? Then I would proceed. Okay. Aman Raju. Okay, Raju, thank you so much. Okay, we would move forward. Okay, this idea is quite clear. Can you please repeat where it gets used? Yeah, I would be repeating. I would be telling you where this is getting used. Okay, I would be telling you all this. No problem. Okay. So now the thing is that we know that whenever we talk about cycles, and that connections, cycles. Okay, these are all the things. What are the observations here? The first one is connection. The second observation is cycle. Okay. So observations are we need a connection and we need to detect a cycle. So clearly this is a graph problem. So I am talking when the problem tag is not given. But if the problem tag is given, it would be very easy. Okay. Now whenever we know that if it is a graph, so the first thing is that we need to implement the graph. अगर मुझे पता चल गया कि मुझे देश का भला करना है, तो फर्स्ट थिंग इज दैट आई नीड टू नो कि यहाँ के पर्सन्स कैसे हैं, यहाँ की पब्लिक कैसी है. इन द सेम वे when I know that it is a problem of graph, the first thing is that I need to see how can I implement graph. Now there are two implementations of graph. The first one is directed graph. The next one is undirected graph. Okay. Now what is directed and undirected graph? Directed graph means that suppose this is this is a city A and this is a city B. This means that I can travel from this side to this side and also this side to this side. This is a two-way road. And this is an example of undirected. And now what do you mean by directed? Directed means that this is a city A, this is a city B. Okay. Now if I travel to this part, then this is a directed. Why this is directed? हम लोग दोस्त यार को नहीं बोलते हैं कि अगर मेरे घर आ जाओगे तो वन वे रास्ता है, एक बार आ जाओगे तो जा नहीं पाओगे. Okay, that's the same situation. Okay, directed means भूतिया, एक बार चले गए तो आ नहीं सकते. Undirected means road. There is a two-way road, NH, highway. जा भी सकते हो, आ भी सकते हो. Okay, now we would move forward. Now what is this graph? Okay, so we would see the connections. Okay, we would see the connection that we can travel in both the direction or we can travel in only one direction. Okay, so now the next thing is that to complete the task 1, I need to complete the task 0. But is the question telling that these two are equally dependent? Like I am telling you, to complete the task 1, I need to complete the task 0. But to complete the task 0, I need to complete the task 1. Is this given or not? When a particular connection is given, I just need to check if the inverse of that connection is available or not. Okay? If this is available or not, just check this condition and you would be clear to go. Like I am telling you, अगर हमें पता है कि यहाँ A से B जाना है, तो हमें कैसे पता लगेगा कि वो डायरेक्टेड है या अनडायरेक्टेड है? We just need to check that A से B तो जा ही सकते हैं. Now I need to check if I can travel from B to A also. Okay, if I can travel both the direction, then it is undirected, else it is directed. So this condition does not imply here. So we can now conclude that this is a directed graph. Can I have a quick +1 that you have understood this? Okay, now I would be moving forward. Okay, this is a directed graph, good to go. So now we would be moving forward. Okay, now the problem boils down to the fact that we need to check cycle in a directed graph. Okay, we need to check cycle in a directed graph. Now how can we check cycle in a directed graph? Okay. Now that undirected, how can we check for undirected graph? We can check for undirected graph by keeping a parent and a child. Okay, so if you are at this position and you are check cycle in a directed graph. So what I prescribe you is that if you don't know how to check cycle in undirected graph, then you must do that. Why you should do that? Because it gets an idea that why that undirected idea can't be implemented here. Okay, then it would be quite clear. But I can't explain you that, because if I start explaining the undirected graphs, directed graphs, and then implementing this in the question, then this video would be very long and you would be out of patience. Okay, that's why what I recommend you is that consider seeing the solution for finding cycle in an undirected graph. If you don't find a solution, text me on LinkedIn. My username is Siddharth Hazra. I would be glad to explain you. Okay, good to go. Okay, now how can we check cycle in an undirected graph? Okay. Now to check the cycle in an undirected graph, the way is that we keep two visited arrays. Okay, and one array would tell us that what are the nodes visited. Okay, and the second one would tell us visited nodes in the current recursion stack. Okay, visited nodes in current recursion stack. This is a predefined way. This is how. Now there might be one question that why we can't use that same DFS approach, the parent and the child approach, in the directed graph also, but we are not doing a normal series part. And if you want, just text me in the chat itself if you want to know why that undirected idea can't be implemented in this directed part. Just ask me, I would be glad to explain you, but I don't know if you want that or not. I am not aware of that. So just let me know. Okay, this is a predefined part, that's why I'm explaining it. Okay, and now we would be keeping two visited arrays, and the idea is quite simple, that in the recursion I would be passing a source, and then what I would be doing is at first I would be marking it as visited is equals to true. Okay, just like backtracking itself, backtracking idea, just kind of backtracking, not backtracking. So next we would do is we would visit neighbors of S, and then what we would do is we would mark S unvisited in secondary. Good to go. This is what we would do. What this would do is I am telling you, and the second array would also be marked as visited. So what we would do is, suppose this is visited, this would remain marked the visited, okay, and the nodes which are not visited will be marked as not, okay, not visited. Now the next thing is that this is visited, okay, this would be visited in the recursion stack, and when this recursion would be over, this would be again marked unvisited. This is how it is done. After all this visiting of the other nodes, it would be done. Okay. So can I have a quick +1 in the chat if I can move to the implementation now? Because moving to the implementation kind of destroys the whole flavor. Okay. So I would be going to the implementation now, and the crisps, okay, and the tasty part of the explanation would be over. So can I move to the implementation now? Just give me +1, or as the video count, the video count is very less, okay, I would be moving on to the implementation. The number of live viewers is 7 and the number of likes is only 4. So can everyone just like the video? Just like the video, it won't cost you anything, just like the video. Okay, good to go. Okay, so now what we would do is we would use the same idea. We are marking the node visited. We are marking the node in the temporary array. Our name is a TP. It is a okay. And now we are visiting the neighbors of the graph. It is a common use. And then if it is not visited, then we are visiting it. Okay. And if it is already visited, if this is visited, if visited is also true and the second one is also true, that means we are visiting it again in the same recursion track, then this means that we are coming across a cycle. Okay, now again we would be marking as not true. If we are coming at this position, then we would be returning false. Okay, and now you would be asking me that I am not passing the other two arrays. It's because I am a very big fan of declaring variables as global, and I keep to pass the parameters as low as possible. Okay, why? Because it makes the program very much understandable. Okay, so I have declared the visited array and the temporary array at the top only, so that the code would be very clean. Okay, and it would be very easy to understand. Those who fear about the DFS or the graph part, it is very easy. See how easy it is. Just the normal DFS code, which is of 2 lines, we are just increasing a little bit, and we are solving questions of Microsoft, Amazon, Google. Okay, and if you come across a good company and it does a machine test, then graph and DP problems are a must. Okay, so you should consider. I was not able to do this, but finally understood the solution. Thanks, bro. I'm very much happy that you are able to understand by my solution. Thanks a lot. Okay. And I too understood very well by explaining you. Okay. So now the main part. So what we are doing is we are making a we are increasing the size of the graph. Okay, as usual I am a very big fan of declaring as global variable. I have already declared it. I'm just resizing it, and next what I am doing is I am pushing e dot first to e dot second. What does this mean? This means that e dot first is having a relation with e dot second. Good to go. So now we are initializing the visited as 0, false means, and this also false. And then we are iterating from 0 to n minus 1. If it is not visited, we would just visit. Okay. And if this returns true, that means that it is not possible. So we are returning false. At the end, if you have not come across this solution, then it is true itself. So just tell me the part where you have not understood, because because it is quite a difficult but interesting question. Difficult but interesting. Okay, no problem, sister. Thank you so much, Pankhudi, for attending this session. Okay, so can I have a quick plus one that you have understood this solution? Okay, and now if you are new to solving graph problems, so next thing is that you should always try, this is a common technique what I have implemented myself. Everyone has their own style of coding and I am not against it, but if you don't have a normal coding style of your own, then you should consider copying this style. Why copying this style? Because writing the DP solution also, if you take two variables and declare the rest of the variables as the global, then even it would be very easy to take the size of the array. It would be very easy to get the complexity and all. And next thing is that implementing the DFS and the graph problem seems very clean and very easy. That's why it becomes very much easy. So now I would be starting a timer of 1 minute, and tell me. Okay. Okay. So just if I don't get any query in the 1 minute, then I would be turning this session off. And just like and comment the video if possible, because the YouTube algorithm is such that it offers the video which is having more number of likes and comments. Okay, good to go. So now just okay. Thank you, Swagger. Thank you, Ankita. Thank you, Anmol. Thank you, Manav. Okay. Thank you, Pankuri. And Raju, thank you. And no more. Yeah. Okay. Thank you to each and everyone for joining this session. I hope that you have liked my explanation and you would come again tomorrow. Okay, I wish that. Okay. So that's all for today. Thank you and have a nice day. I would be turning this session off. Most welcome, Swagger.